Hey guys, let's talk about related rates. So, what is a related rate? So, a related rate is basically in calculus. It's kind of like a life example of when we can use calculus and when it can be applied to real life situations. So let's start with this for example. You're pouring out water from a cup, and as the water goes on the floor, let's say it makes a perfect circle. The rate at which the water is leaving the bottle or the cup is gonna be one thing, and then there's also a rate of how large the radius of the circle of the puddle is going to become. So basically, if you notice, related rates all has to do with time. So we're differentiating with respect to time. So let's start with this question. A spherical balloon is being inflated so that its volume increases at a rate of 100 centimeters cubed per second. How fast is the radius increasing when r equals 5 centimeters? So we are given this formula, which we are going to need. So we'll keep that in mind. And let's start with this. Let's start with highlighting some important things. Increase whenever you see like a rate stuff. You know that right there is a volume with respect to time, as it shows right here. I mean, you have the volume, and then you have another unit, which is time right there. So that is basically dv by dt, right? And then you got r over here. So we know what our r is, and we gotta figure out what is dr by dt. So let's start. We have our equation, which is right over here, and let's start differentiating it. So use implicit differentiation. So what's the derivative of v? Well, it would just be 1, so dv by dt. Because that's implicit differentiation. For this part, we can pull out our constants for now and just differentiate our r cubed, which is 3r squared, using the power rule. So and then times dr by dt, of course, because it's implicit differentiation. Now we have a pretty clean thing here, and we can start plugging in, but I want to simplify as much as I can just to make it as clean as possible. So what can I simplify? Well, if you notice, all this is multiplying. All this is multiplying. And we have divide by 3 here, and we have multiplying by 3 here, so they cancel out. And now we can simplify this. Oh, but what the hell is that? Now we can simplify this by writing this. Okay, now it's time for us to start plugging in what we know. So what is dv by dt? Well, we have to look at where there is a unit of volume and time. Here we have a unit of volume, and here we have a unit of time. So our dv by dt is 100. We'll write that down. 4 pi. What's our r? We want to know what it is at 5 centimeters. So we'll plug in 5. And then we're solving for dr by dt. Now, here's just a little trick I'm going to give you guys to keep your neat. To keep your work neat. Yes, you can multiply it by pi, but you really don't have to. And I don't suggest it, because think about it. What is pi? Well, it's 3.14159265358 and so on. And it doesn't stop. But just treat pi like a variable. So we can just multiply the 4 times 5 squared and write that as this. So, well, who the hell are you? Now, what is 5 squared? This is 25 times 4. That's 100. Now, yes, you can multiply 100 by pi, and that would be what, like 300, 14, and so on, or something like that. Or, yeah, I think so. Anyways, now we'll bring our 100 pi and divide it by both sides. So this divided by 100 pi, this divided by 100 pi, to isolate the by dt. And this is why we keep our pi as a variable, because it would be so unorganized if we did not. What is 100 divided by 100 pi? Well, the 100s just cancel out. Now you have 1 over pi equals dr by dt. So that is your final answer. This is your final answer to the question. It was extremely easy, and I hope you guys understand now how related rates take place. All right, thank you for watching. I hope you guys have a great day.